Yep. You lying. All right, so let's go through these. Now, here's the deal. What I'm going to do is I'm going to try to cover all 3 different topics in this one little section. And I'll be glad to answer any other questions that you have. But I'm looking at the test right here. It's in my hands. Okay, I made it this morning. No, you cannot look at it. So here's what the test is going to consist of. You may want to write this down. The first 10 are simply telling me what type of reaction it is. That's it. You look at it and you say, is it synthesis, decomp, double replacement, single replacement, acid, base, or combustion? That's the first 10. Pretty simple. All right, the next 10, all balanced. That's all you have to do. Balance. Yes. The next 5, and I'm going to kind of talk about it, are all single replacement problems. What do you have to use for single replacement problems? What? The activity scale. That little half sheet. 21 through 25. That little half sheet. Okay, and I'm going to go over that today.
Yeah, we get use that half sheet, right?
Yes, you get to have it. What happened to him? Here. Now, so not only do you have to tell, can it work? You need one too? Okay. Not only do you tell, can it work, once you determine if it can work, then you have to finish the products. You have to write what the products will be. You have to swap places and write the end result. Okay? And the last 3 are just like this. It's the words. You have to write the equation, balance it, and tell me the type. And that's it. That's it. That's the test. It's 28, but those last 3 are worth more points. Write words, balance, and tell me the type. This whole first page that we're fixing to cover. Yep. And the only reason there's 3 is because of time. No, because of time. There will be more on the next one. Okay. All right, so let's look at the first one. Again, don't overthink these things. By the time I'm done with this, I want you to be able to just breeze through this without any hesitation, without any trouble at all. Chris, you awake? You sure? All right. So when it says zinc, what are you going to put? All right, Zn. Not that letter. I don't know. The pen messed up. All right, so Zn and lead, 2 nitrate. So what's the first thing I need to put between those things? I need to put a plus sign. Lead 2 nitrate. Is that a compound? What do you do with all compounds? Check the charges. What is this 2? Is that the subscript? No, that is the charge. Where do charges go? Okay, so this is Pb 2 plus. Everybody okay with that? What is nitrate? NO3 what? Negative. Very good. So when you crisscross that, what do you get? Very good. PbNO3. It's the pen. All right. React to form. As soon as you see that phrase, what does that tell you? Okay. Now, what are some other ways you could potentially see that? Yields, produces, makes, creates, combines to, blah, 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 blah. Okay. So just look for a vocabulary word that will give you an essence of the terms that it's being produced. All right. React to form zinc nitrate. Is that a compound? What do you do with all compounds? What is zinc's charge always? Zn2 plus. All right, nitrate is NO3 negative. So when you crisscross that, what do you do? Zn, N, why is this pen so messed up? NO3, 2, and then it says and lead. So what does that mean? Plus Pb. Now, why does the Pb nor the zinc have a 2 behind it? They're not diatomics. They're not diatomics. All right, so my first question to you, number 1, Is it balanced? Is it? It is balanced. Let's look and see. How many ZNs? How many PBs? All right, let's try this again. Reactant ZN, 1. Product ZN. A reactant lead, product lead. Reactant nitrate. Why did I do them together? When is the only time you can do them as a polyatomic? You got to be on both sides. So there's 2 nitrates, 2 nitrates. You're balanced. Last question. What type of reaction? Okay. Now, I'm glad you said that, but let me explain that. This is a single replacement reaction. All right, so very good. So it's a single replacement. We have one element mixed with a compound, and then all of a sudden over here we have another element that's kicked out on its own. What must you do in order to tell if this is even possible? Check what? The activity series. Get that little half sheet out. Okay. Again, tomorrow you will get one, but you need to be looking at it right now. All right, so how will we know if zinc... Now, first of all, what is zinc going to kick out? Why? Metals replace metals, and zinc is a metal. How will we know if zinc can even replace lead? If it's above or below? Got to be above. Is zinc above lead? So yes, this one will work. I mean, this is a combination of all of them. One of them, you will see the fact that this is a single, like you will see this formula. You got to tell me what is it. No. That's a good question. For the single replacement problems, the way you're going to see it is just like this. It'll be like that. That's what it's going to show up like. Okay? And it's going to, the first question you're going to have to determine is, can this work? If it can work, you're going to have to you're going to have to swap them around and write the products. That's it. My question to you is, what do you do if it does not work? You will write no reaction.
So is that double replacement?
That's just single. Okay? Just single. So if it will not work, you'll write no reaction. That's it.
Are we going to have to do anything about the redox?
No redox.
That's the only thing I understood.
But I don't. I had a lot more time in here to go over it. First and sixth period, because it's so much shorter, they struggle through it. So I need more time with them. That's the only reason why. Yes, ma'am. Come up here.
What if a bonus?
What?
Double.
What are you talking about?
Is there going to be a bonus?
No. I tell you what, I could do a redox for bonus. How about that? We'll do that. I'll do a redox for bonus.
30, 40 points.
60. How about that? Huh?
That means I make it 60.
It's not going to be. No, I haven't made the copies yet. I'll go back in and I'll add some bonus problems that are redox. I'll do that. Okay. I haven't made copies yet, so I can go back in and edit it. All right. Let's look at the second one. Aluminum bromide. Is that a compound? Okay. All right. I'm going to start going around the room. Bryce, aluminum bromide. What do you have to do? Very good. Aluminum is +3. BR what? Do me a favor, Manya. Will you pass those out? What's bromide? Why? Very good. So when you crisscross, what do you get? Very good. AlBr3. All right, Joanza. And chlorine gas. What are you going to write? Very good. Everybody, why is there a 2 behind chlorine? Okay, do not forget the gun. That will destroy your grade if you don't put the diatomics. Now, react to form. What is that going to give us? The arrow, right? All right, Trevor, aluminum chloride. Is that a compound? What's your charges? Very good. Al is a 3 plus. Chloride is a... Very good. So when you crisscross, what do you get? Very good. All right, Kalen. And bromine gas. What are you going to put? Very good. Why is the 2 there? Very good. Everybody good with that? Now, my next question, Christiana, is it balanced? No? All right. How many ALs on the left? This is Christiana. How many? How many on the right? All right. BR's on the left. BR's on the right. All right. How can I balance those? There's a rule for this one. Very good. Anytime you see a 3, put a what? Put a 2. How do I make this one? Put a 3. Very good. All right. Now, that just altered my aluminums. I have 2 over here. How many do I need over here? 2. Did that just balance my chlorines? Nope. How many on the right? 6. And I need how many over here? I need a 3, right? Okay. That's balanced. So that's balanced. All right. Krista, what type of reaction is this? Very good. It is a single replacement. Now, I need you to pay attention here. How can you tell it's a single replacement? Krista? All right. So Cl was by itself, and it came over here and replaced bromine. This is where you're going to mess up if you don't catch this. Why did Cl replace Br and not replace Al? Very good. Al is a metal. Metals only replace non-metals, which is what Cl is, replace non-metals. When you have that half sheet, find the sign that's by itself. Cl is on which side of that half sheet? Can you cross sides? No, you got to stay on the same side. So this is a single replacement reaction. Go ahead. Let me see you. Come see me and I'll explain it. Okay? Unless Bryce can explain it to you, that would be nice. Okay? All right, Jonathan. Sodium phosphate. Is that a compound? What's your charges? All right, so Na plus and phosphate is what? Very good. PO43 negative. So when you crisscross, what do you have? Yep. Very good. PO4. Everybody good there? All right, Carson. And calcium chloride. Is that a compound? What do you do? Okay, what's calcium? C plus. Why 2 plus? Very good. Chloride is? Why 1 negative? Group 17. So when you crisscross, what do you get? Very good. Now, I'm going to stop right here. And just looking at this, Alec, just looking at this, what kind of reaction will this be? I have 2 compounds. This is a double replacement reaction. You said single.
I said double.
You said single.
I swear on everything I said double.
I didn't hear.
It doesn't matter.
This is a double replacement reaction. And again, why is it double? There are 2 compounds, and they're going to swap places. Now, in a double replacement, what do we say swapped places?
Metals and metals and non-metals.
Okay, so Na is now going to be with who? Cl. Does everybody agree with that? And then Ca is now going to be with who? Are all of those brand new compounds? What do you always do with new compounds? Check your charges. So if it did not have the words react to form calcium phosphate and sodium chloride, could you still figure this out? Yes. That's our goal long term, is I can give you this and you can figure out the rest of it. That's our goal. It's not hard. So I could get rid of the words. I know that Na is now going to be with Cl, correct? What is the charge of Na? Plus 1. What's the charge of Cl? Negative 1. So plus 1, negative 1, what happens? NaCl, they cancel. All right. Then we have calcium phosphate. What is the charge of calcium? All right. Ca is a 2 plus. What's phosphate? PO4 what? 3 negative. So what's it going to be? Ca3 PO4 2. Now, why did you put PO4 in parentheses? Exactly. If you put 42, that just looks ridiculous. Okay? Polyatomics must go in parentheses. So could you potentially figure this out? Yeah, it's pretty easy. Yes, ma'am. No. Now, the wording has second. I just did it out of order just because. But that's a good question. Does it matter which order we put them in? Not at all. As long as it's Na, then Cl with the correct subscripts, Ca, PO4 with the correct subscripts, you can move them interchangeably. Doesn't matter. All right. Chris, is it balanced? Okay. I have 3 Nas, 1 Na. I have how many phosphates? Yep. 1 over here I have 2. So let's balance that one first. All right, so I have 2 phosphates. I have how many Cas? How many over here? 3. So I need a 3 right here, right? How many Nas? 6. So what do I need right here? 6. How many Cls? 6. So I'm good, right? So that's balanced. How would you write the correct answer? Sorry, I haven't been doing this yet. How are you going to give me the correct answer? Very good. 2, 3, 6. No, you just, tomorrow on the answer, you'll write number 10. 2, 3, 6, 1. And that's what I'm going to look for. What? Oh, yeah, whatever order it's in. It'll be in a specific order tomorrow. You don't have to write them out. Okay. Well, the last set, write it in the order that it's written. But if whatever, you get what I'm saying. Okay. All right. Moving on. Cannon, potassium metal. What am I going to write? Just K. Why is it not K2? Very good. Potassium's not a diatomic. Why did I write it? Yes, sir. Are you done? Or you got a question? Hang on one second. All right. Seth, chlorine gas. YCl2. Very good. So diatomic. Combine to form potassium chloride. Keely, what are you going to do there? Why? It's a compound. What do you do with compounds?
Check your charges.
What's that? That crisscross thing. That kind of yeah, that thing. Why is it KCl? What are your where'd your charges go? They're both they're 1s, so they cancel. 1 plus and 1 minus. All right. Peyton, is it balanced? No, let's balance it. Peyton, 1K. How many Ks? How many CLs? How many CLs? So how do I balance it? What else did that affect? So what do I do? Very good. Yes, ma'am, Manya?
So the diatomic thingy only matters if it's single.
Bingo. Listen to this. Why did I not put a 2 back here? Well, there's a Cl. That's a diatomic. No. Because it's with K. You're exactly right. The only time it's, quote, a diatomic is when it's by itself. You'll never write that letter by itself ever. Okay? You got a question or you just hanging out? That's fine. All right, real quick. What type of reaction is this? You take A and you take B, you make AB. So this is a synthesis reaction. This is a synthesis. What's wrong? The gun and the bullet. That's it. Zinc is not one. It's a single plus a compound. That was a single and a single. That's like A plus BX makes AX plus B. Yes, in the notes. Yes, ma'am. I can't hear you. Okay. What?
Okay, so the backstory is the substitute leader. They have clubs that day. He doesn't think the club. He doesn't think they have clubs, and so he asks anybody who has a valid excuse to leave the class. Can I go pick up a shoe?
Who is Tomoki?
He's the only black kid in the class.
Is that real? Like here?
It's a Comedy Central.
Whatever. Whatever. All right, so aluminum and hydrochloric acid. So let's look. Miss Morgan, aluminum. What you going to write? AL, very good. Alex, hydrochloric acid. Very good. HCl. Before I go any further, I should be able to recognize what kind of reaction this is simply by looking at this. It's a single plus a compound. Single replacement. Before I ever begin, you can know that. Now, here's the deal. What must you look at in order to tell if a single replacement is even possible? Activity series. What are you going to be swapping Al with potentially? H. Why? H is a metal when it's with an acid. Very good. It acts as a cation. Is this even possible? Yes. Why? Exactly. Al is higher than H on that list. So this will work. So Al is now going to be with who? Cl. Is that a brand new compound? What do you always do with compounds? Check your charges. So, yes. So, aluminum chloride is AlCl3. Why? Very good. Aluminum is 3 plus. And hydrogen gas. What are you going to put? Just H? I want to just put H. Can I do that? No, I can't do that. Why? You will get shot if you don't. That diatomic gun is going to get you. Or that. I'd have to report that. Is it balanced? Alec, is it balanced? It is balanced? How many ALs? All right, how many ALs here? Why are you standing up? How many H's? How many H's? All right, how many CLs? How many CLs? All right, now, I'm going to be honest. This was kind of funky. You got to play with this one for just a second to figure this one out. All right, so if I put a 3, and if I put a 3 right here, that's going to give me how many H's? 3 H's. Well, then I've got 2. That doesn't really help me out, right? It is the 2-3-6 rule, but the problem is I've got to get a 6 in here somewhere, so I've got to figure out where that 6 is going to go. Slow down. Slow down. This is not ghetto rap music time. Exactly what I just said. Yes. I don't get in a coffin when you guys leave every day. I'm a human. All right. It's a 2. It's the pen. All right. Shh. Please listen. Here's the deal. Again, that one's kind of funky. You're going to have to play with that one a little bit to get it to balance. It takes some looking around and messing with. But again, bottom line, you need to be able to recognize this is single replacement, and you need to be able to potentially predict the products. Go ahead. It is a 2. It's the pen. I'm not doing it intentionally. I need one. I really do. The library has them. They're free. Sit down. No, I don't. I'll go get it if I need it. Now, calcium hydroxide. CaOH2. How in the world did I know that was CaOH2 and not just CaOH? Calcium is a 2+. Very good. OH is a what? 1 negative. Okay. Right here if you're finished. I gave you phosphoric acid. What's phosphoric acid? H3PO4. Now here's the thing. You potentially could have figured that out. Here's why. What is the charge of H? H plus phosphorus or phosphate is 3 negative. So that's where that comes from. Phosphoric acid, okay? Remember, all acids must have a what at the front of it? An H. Must have an H. Before I go any further, what kind of reaction? Be more specific. Very good. This is an acid base. You have to recognize that. First and foremost, how do you know that this is an acid? Well, it says an acid. You are going to have to learn how to recognize what bases are. What is a base? It's something that is a metal and a hydroxide mixed together. Please listen. It's a metal. Are y'all listening at all? Because you're going to see this tomorrow. If you don't get it, you will get it wrong. This is a base, a metal and a hydroxide. So this is an acid-base reaction. And if you put double replacement, it is wrong. Yes, it looks like a double replacement. It is a type of double replacement. Answers on front. It is a type of double replacement, but specifically, it is an acid-base reaction. And you have to be specific as possible. So that is an acid-base. All right, so let's go on and let's write what it will be. Now, since it is a special type of double replacement reaction, who is Ca now going to want to be with? PO4. Very good. Is that a brand new compound? What do you do? Ca is a what charge? 2+. Phosphate is a 3. So when you crisscross, you should get Ca3. Very good. PO4 2. Now, H is now going to be with want to be with what? OH. So that is HOH.
H2O.
Or water. Does it matter what way you write it? I don't care. The only time you can write HOH is in an acid base. The only time you can write HOH is in an acid-base reaction. Yeah, you should always get water. Because all acid-base reactions produce a salt and a water. What is the salt? Calcium phosphate. Very good. Calcium phosphate is your salt. All right, number 7.
Can you just use that, like what it produces, to figure out if it's an acid or base?
No. Because there's some things that produce waters that don't necessarily produce salts.
That's what I'm saying. Like,
Because it could be sodium nitrate and sulfuric acid, and that's not an acid base. Was it not balanced? Well, let's go back and balance it. My apologies. Yeah, let's balance it. I got off to thinking about something else. All right. Now, to balance this, would it be easier to write it as water or HOH? HOH is...
What'd you do?
I really have no clue what I did.
Press the button.
I don't know. Nothing you don't want to know. All right. So this is that. Blah, blah, blah. So let's write this as HOH. It's a little bit easier to balance it like this. All right. How many CAs on the left? CAs on the right. So how do I make them balance?
3 on that one.
I need a 3. Please listen. All right, so that's 3. All right, how many phosphates do I have on the left?
4.
Phosphates on the right.
2.
What's wrong? You okay? You just messed your bracket up, didn't you?
Wait.
Cut it off.
Say again.
Cut it off. Yeah, they just went up by 1. I have it on up here too. It's okay.
Wait, what's the score?
They just went up by 1.
It's 59-58.
Ohio?
That was a sick up and under though.
This is recorded.
I don't care. Whatever. All right, so we have 1 phosphate, 2 phosphates. Let me know when it comes back on. So I need 2 right here. But look, how many hydroxides did that give me?
Wait, how come you don't sing for us?
How many hydroxides did that give me? 6. How many hydrogens? 6. So really all I need is a 6 right there. Okay? I sang? Did I? Oh, I did sing. That's right, I did. It was a little tune. It wasn't like a song.
What did you sing to us and it was funny?
All right, so I need to do the one above this one. Copper and sulfuric acid. All right, who have I not finished? Miss Natalie, copper, what are you going to write? See you, very good. All right, Fuller, sulfuric acid. I gave you this one. Very good, H2SO4. Now let me ask you this. Just because it has an acid, is this one an acid base? Why? There is no base. Okay? There is no base. Now, I need to ask you something. Just looking at this, what kind of reaction is this? It is a single replacement. What must you use in order to determine if it's a single replacement reaction? Activity series.
It's only for single replacement?
Only for single replacement. Look on your activity series and see if it'll work.
How's your bracket doing? Oh, not good.
Not good. Yeah.
No.
Yeah. All right, so look and see.
That is a long bracket.
Look and see if this will work. We'll see you replace H. Hello? You sure? I need everybody to say this.
Yes.
Is CU above H? No. So really, they kind of tricked you here. What should you put? No reaction. So really, that's a trick question.
What ones are those doing the test for?
Yes. So this is no reaction.
Is it supposed to rain?
Everybody just, millions of people just lost $1 billion. All right. Chemically speaking, no. Now, I mean, you can write it out. It works on paper. But if I go in the back and I get a piece of copper and I get sulfuric acid and I mix it, that sulfuric acid will not eat that copper. That's why we use copper in a lot of welding and pipes and stuff. So if there's ever an acid that gets on it, the copper won't dissolve. Does that make sense? Like if you pour Drano down a drain and there's copper piping, it would eat through it if it was able to be dissolved, right? That's why we use copper for a lot of stuff. We don't use magnesiums and all of the softer metals. So anything that's above H, we try not to use as anything that could be corrosive. What does corrosive mean? Or basically eaten away by an acid, right? So that's why a lot of lead stuff we don't want to use anymore. So we use copper, we use silver, platinum, things of that nature. It can't be reduced very easily. Okay? Yes, sir.
Why are there like 3 different things on the reactant side?
Copper and sulfuric acid react to form copper 2 sulfate and water and sulfur dioxide.
Why do they do that?
Sometimes it just does that.
So that's what we put.
If it works,
If it worked, that's what it would produce.
Is it supposed to rain today?
Not that I'm aware of. All right, so last one. Hydrogen gas. What are you going to put?
H2.
H2. Now, notice this next one. It's a little different than we've seen. What do you see that's special?
Nitrogen monoxide.
You see prefixes. If you see a prefix, throw a party. Write what you see. What do you see?
NO2. I mean, NO.
Nitrogen monoxide. Yes? No, that's yes.
Yes, it's no.
To form water, which is, and nitrogen gas. You just going to put in? I'm just going to put in.
N2.
No, it's in.
You'll be shocked.
Yeah, I'm going to get shot. N2. Okay. Is it balanced? Nope. We need to balance it.
Actually, N is the only natural.
But it can throw something else off. So that throws my O's off. So that gives me gives me 2, and now it's still unbalanced. So what do I need? I need a 2 there. Any questions about that? All right, now I don't have the ability to pull up the worksheet that's the very back page because I don't have a digital copy of it. But I want y'all to flip over, and I want to go over that real quick, so you can make sure you have the right answers. The back page. Go ahead. You sure? Okay. All right. So I guess the what? On which one? Okay. Do you want me to flip over a page? You just messed it up. No, it's a commercial. All right. On this one? All right, guys. She asked me to do some specific ones. You say 7 and 15? All right, so let's do 7. Yeah, go ahead. All right, this one's kind of funky because if you notice, you've got 2 oxygens on the left and 3 on the right. You with me?
Is that the same as the yield sign?
Yes. I just did equilibrium, yeah. It's the same thing as the yield. You'll get there. Okay, it's a habit. AP, I've been doing this for weeks now. 7. All right, so I have 2 hydrogens, I'm good. 2 oxygens, 3 oxygens. Now, I know how to do this, but this is what I'm going to do. If I mess with this O, that's going to just throw some things off. Because if I put a 2 in front of this O2, that's 4 plus 1 is, that gives me an odd number. I never want an odd number. Odds make things complicated. So let's try and let's put a 2 here. So now how many O's do you have?
2, 4.
I've got 4. Well, if I put a 2 here, it's balanced.
Oh.
Now, does that make sense?
What's the equilibrium sign?
What?
What's the equilibrium sign?
It's an equilibrium. It's more specifically like this. It's just an arrow going both ways.
What's it mean?
Means that it's a reversible reaction. At the same time this is decomposing, somewhere else in that same reaction, it's reforming. Okay. This is 99% of all reactions. Very few reactions go to completion. There's only 2 types that go to completion. Solubility of soluble salts, or the dissolution of soluble salts. Most are like that. Or acid-base neutralizations go to completion. Okay. All right, another one. Natalie, you said? 15. Kind of put all your eggs in one basket, didn't you? Well, the March Madness world just exploded. All right, here, let's look at this now. Natalie, there's something we can do here to make this a whole lot easier for us. What can we do to make this easier? Change water to HOH. Why would that make it easier? Because then you have hydroxide on both sides. So we're going to change this to HOH. All right? Now, I have 1 K, 2 Ks. So what does that mean? I needed 2 right here. Well, how many hydroxides did that just give me? 2 hydroxides. I put a 2 here. I'm done. That just gave me 2 H's, and I still only have 1 SO4. So how would you display this answer? 2, 1, 1, 2. Does everybody know that's the style you have to do it in tomorrow, right?
Yes, sir.
Okay. All right. Anybody else on this side? Any other ones? All right. Flip over. This is the page I'm looking on. This one right here. Okay. Number 1. What type of reaction is that? This is combustion. Now, there is a tip to do these. What was that trick that I taught you? Double the first one, but then you must what at the end? Reduce. It's not necessarily 2, but reduce if you can. Okay? All right, so we're going to put a 2 here. That just gave me 2 carbons, so I need 2 carbons. How many water or H's? 8, so put a 4 here. 2 times 2 is plus 4 is 8. What is half of 8? 4. Can you reduce? Yes. So 1, 2, 1, 2. You could still work, but a lot of combustion reactions, if you double it, it's most of the time you don't have to reduce. Most combustion reactions don't reduce. This one is one of the ones that does. A lot of the ones don't. And I haven't figured out a theme yet, but I think if you have an odd number carbon, it won't reduce. If you have an even number carbon, it will reduce. I think that's the case, but don't hold me to that. This one isn't, because a rare exception of the rule. That's combustion. Remember, if it has a hydrocarbon plus oxygen and it produces CO2 and water, it's combustion. All right, listen. What about number 2? What kind of reaction? A plus B makes AB, so that is a synthesis reaction. Balance it on your own. What about 3? 3 is single. Everybody get that? Be very careful here. 4. That's decomposition. You're taking that compound and what are you doing with it? You're splitting it in half. 5. Synthesis. You're sticking 2 things together. 6. Be very careful here. That is a double replacement. That one, do you even have to balance that one? It's balanced for you already. 7. Decomposition. 7. Synthesis. Sorry, 7 is decomp. 8. Synthesis. 9. Single. Do me a favor. Can this one work? Look on your activity series. It's copper above silver. Yes, only by 1, or by 2, but it'll work. And 10. That is a double replacement.
Will there be any that you feel earlier on the test?
Yep.
When we get to use those.
Yep. Real quick, I want to practice this one. This is on the very back, number 8. You guys realize this is actually wrong?
Yeah.
What's wrong with it?
It shouldn't be.
It should be S8. But I'm going to write it how it has it. For bonus, redox reactions. What's your first rule? Look for zeros. Where are your zeros? Yes? Next step. Look for your metals. Where's your metal? It's a what? All right, so what happened numerically? It went up, so that means sulfur had to do what? Sulfur had to go down, so when it goes down, what do we call it? If it goes down, you lose, so it is reduction. So this is oxidation, oil rig. It's the very last one, number 7 on your new. This is 7 on the very, very back. But what type of reaction is this other than redox? This is synthesis. This is A plus B makes AB. All right. Let's do number 10 just for practice. That is combustion. Combustion, what's the tip or the trick? Double it. That means I have 8, so I need 8. That means I have 20, so I have 10. How many total oxygens do you have on the right?
2.
8 times 2 is 16 plus 10 is what is half of 26? So Parker, what I told you was wrong. So you see what I mean? This time you can't reduce it. Why can't you reduce that? 13 is an odd number. You can't reduce an odd number. That's it. So 2, 13, 8, 10. Okay. That was 10 on the back. Very bottom one. Is this an oxidation reduction reaction? Yes. All synthesis, all single, and all combustions are all redox. Those three are always redox reactions. Where's your 0 here? O. What did oxygen turn into over there? -2. So oxidation went what numerically? So that is reduction. Hydrogen is a +1 here and a +1 there. So what did it do? Nothing. Fuller, sit down for me a second. Okay. So carbon had to do what? Carbon had to go through oxidation. Had to. So this is combustion and redox. So the way the question is going to be worded, what element went through oxidation? What would you say? Carbon. What element went through reduction? Oxygen. Did I teach all this last year? I don't think I did. But it's easy. So when I get to lecture next year, it'll fly. Yes. Okay. All right. Any other ones you want me to do? I'm trying to do as much as I can do for you. What? Last one. All right, why is this one weird?
It has a 3.
It has a 3 and it has there's 4 on the right. So we got to figure out how to make this even. What can we do? We're going to probably have to test this.
You get 12.
All right, so what I'm going to do is I'm going to put a 2 here gives me 6, correct? 2 here gives me 2 times 2 is 4 plus 2 is 6. And I'm done. So 2, 2, 1. What type of reaction is that? Decomposition. Yeah. All right, real quick. What type of reaction? This is a synthesis. Is that one balanced?
No.
Nope, this one's kind of funky too. So I'm going to put a 2 here. That gave me how many oxygens? 4. So I need a 2 there, right? Okay. All right. Guys, you'll have a good day. Please be prepared for tomorrow.